So today we will take this topic and how we can create such an IoT system so that you can just look at the cooler, or you can look at the refrigerator, you can look at the TV, or you can look at the home light, you can look at the phone, and it will switch on and off, or you can get the user interface of that phone just by looking at that, or you can look at the TV, and TV will automatically switch the channel or turn on or off, or you can look at the AC of on your room and the AC will automatically turn on. So for now, this might looks like a magic, like such technology is not available yet. But yeah, today we are going to make such a futuristic technology. We will try to make a conceptual project on that. Using that, you can able to control the things around you just by looking at it. So this is a conceptual project, and you can convert this conceptual project into a final product by doing more innovation in it. So so let's start our project with the basics requirement, with the talk of the basic requirement of the project. So here we are using the IoT system for the project. So it's obvious that we need a board or module on which we can program and use it as IoT board. So for that, I am using the Raspberry Pi. I am using the Raspberry Pi. As you can see in the camera, here is the Raspberry Pi. So I am using this Raspberry Pi. I will tell you later why I choose the Raspberry Pi. While there are other chips are there like ESP and other chips are there. I will tell you later regarding this. And then I have used the relay as to control the AC appliances. Like you already know that using this using any type of development board like Raspberry Pi or Arduino or any ESP32 board, you can't control the TV or AC lights directly by by using this development board, because they can't handle those AC voltage. So for that we often use the relay, and this is the relay module. Using this relay module, we will control the we will able to control the TV or light by sending the command to this relay module using this Raspberry Pi. So, so now let's discuss why I'm using the Raspberry Pi. I'm using this Raspberry Pi because we are going to use a special system for detecting the object, so that whenever you look at the particular object, this will detect the object and able to turn it off and off, or set or do whatever the function you have set for the thing. Like when you look at the bulb, it will turn it off. When you look at the TV, it will turn it off. So it's a still sound like magic. So we will try to make such a thing live. And for that, I have also used a small uh, glass like this. This is a glass that on which you can mount the Raspberry Pi and the camera on this, like here in the video, as you can see. Let me check the video. Like here in the video, you can see I have a mounted glass with the camera and the Raspberry Pi board. So this whole things can be turned into these things, like this smart eye glass with a camera. So you might have seen the uh, Marvel movie of Iron Man. Like you have seen the many movies or sci-fi movies like Iron Man, where the hero wear a glass like this, and he will able to control the things using this smart glass. He will able to see the holographic display. He will able to get the details of that object, like whenever you look at it. So this technology is going to seem little bit similar to that. And so this whole idea makes it more interesting, because we are connecting the current technology with the future technology and the sci-fi movie. So this is the combination of all those things, and we are going to try to make such a system like Iron Man, and make a smart glass on which you can wear and control the things just by looking at that. So this whole glass that I have showed you earlier can be turned into this with the camera. So so now let's start. We have already talked about the components, and so now let's start making the project. How we can make it, how we can implement it. So for that, we have used the ML model, and for the ML model, and using the ML model, we deploy the ML model on the Raspberry Pi, and we use the Raspberry Pi camera that is mounted on the eyeglass. So whenever it's looking at any particular object like a TV or light, the camera will move according to our eye, and it sends the video to the Raspberry Pi, and the ML model that is trained to detect those objects. It will able to detect the TV, light, or bulb. But and whenever it detected the light, bulb, or TV, it will turn it on and off. So this is the whole concept of the project. Like you might have seen in the sci-fi movies like Iron Man. Whenever Iron Man sees the particular object, it will detect the object and give the details of that person. Whenever Iron Man look at the TV, it will able to turn it on and off or control it using this eyeglass. So this technology is little bit similar to those sci-fi movies, and so it's really going to be a very interesting journey. So let's start our project. So for this, we need to program this Raspberry Pi for the object detection, and we will need to train the ML model. And for that, we have various options. So let's first logging into our Raspberry Pi. Here, here I am using the VNC server that I have connected with the laptop to power the Raspberry Pi and the VNC server, and I will be able to log in into the Raspberry Pi desktop. I enter the password here. So if you, I am taking this session in English. If you are little bit uncomfortable in English language, that I will also try to explain in Hindi. So if you want me to explain in Hindi little bit, you can ask me in the comments. So this is my Raspberry Pi desktop. You can see this desktop on the screen. I hope you will able to see it. If you able to see this Raspberry Pi desktop on your on the video live, then you can comment that yes, it is we are getting this desktop. So for this, we have used the ML model, a pre-trained ML model. Here I have used the TensorFlow. There are lots of different types of ML model and artificial intelligence platforms using which you can train the ML model and run the ML model like PyTorch or TensorFlow, or you can Edge Impulse, and there are various things. So you can use any of them. Here I use a TensorFlow because most of the complex computer vision systems or complex such an object vision system can be easily handled by the TensorFlow. Only demerit of the TensorFlow on the Raspberry Pi is that it takes lots of RAM of the Raspberry Pi. That's why you need a RPi board with the 2 GB or greater RAM. And and another demerit of TensorFlow that it takes lots of time and effort to install it on the RPi. But once it is installed, it is easy to use. So I've already installed the TensorFlow. And if you not know, if you don't know how to install the TensorFlow on the RPi board, you can go to the TensorFlow official website and follow the instruction well, and you will be able to get that thing installed on into the RPi board. After the installation, you will need to install the object detection module. For that, you need to open the terminal, and then you need to install the basic libraries. That those basic libraries are OpenCV, so and DLIV, and TensorFlow and PyTorch, NumPy, and all these libraries. So for installing any of all those libraries, you can use the simple command. If you're using the Python 3, so type sudo pip3 install install, and let's say I am going to open install OpenCV. Then open CV. If I am going to install the DLIV, if I am going to install the NumPy, num NumPy. So uh, you can open the terminal, type this command sudo pip followed with the whatever the modules you want to install. So you need to install the NumPy, TensorFlow, PyTorch. So you can just type the PyTorch. I've already installed that. And so that's why I'm not going to install it again, because if I install this all the module again and type and run this syntax, then it might create a conflicts between the different modules, latest version modules, and the old modules, and create a conflict with running the code. So I'm not going to do it right now because I've already installed. But you can follow these commands like sudo apt install sudo pip install dliv for and OpenCV for getting the camera interface of the Raspberry Pi, tracing the camera with Raspberry Pi, and getting the video of that thing, and and so after a lot of TensorFlow to getting the TensorFlow installed on the Raspberry Pi, and then after getting all these things installed, you need to clone the modules of the object detection module. You find it on the internet. After getting this live session, I will send you the link of the article by which you can follow the steps to do those things to installation of TensorFlow and object detection module on the RPi board, and you will able to get those things. So you can this whole project is already published in electrons for you can search IoT on EFY in the Google Chrome, and you will get the whole article of that, and you will follow the steps, install those things and prepare those things. So this is live session. That's why I'm only focusing the things in explanation of those things. So after installing then cloning the object detection module, uh, you will get a folder like this. Here you find a folder of research, and in the research folder, uh, you need to go into the object detection folder, and this is our object detection folder. So here I'm going to use the IoT system for the here I'm going to use the object detection system, the computer vision and the TensorFlow for detecting the different appliances around me, like the TV, fridge, and camera. So for that, I have to first declare those objects that I want to that I want to uh, that I want my ML model to be detected. So I'm using the pre-trained model SSD mobile net model. You can see the modules here. So here you need to create a pv.txt file, new pv.txt file or IoT and I.pv.txt file. Sorry for that. Uh, so suppose that this is the pv.txt file. I'm opening it in text editor. So this is a pv.txt file in which we contain all the set of things that we want our camera to be detected from the pre-trained object detection module that we have already told you about SSD mobile net module. So this the pre-trained SSD mobile net module that will get cloned on the RFI module, be able to detect all those things, but we do not need in our IoT or I system to detect all those glass, suit, apartment, bird, sports. All these things are not needed to be detected by our camera, because for our IoT and I system, we only want our camera to detect the refrigerator, bulb, or the TV, or phones to switch on and off and control those electronic appliances. So we will remove all those parts, and we will create another file with the name of IoT on i.pv.txt, and using this we will try to detect these objects, electronic objects that we want to control, like the hair dryer. So whenever you look at the hair dryer, the hair dryer will turn on, and when you look at again at the hair dryer will turn off. So whenever you want to turn on the refrigerator at your home, you can look at the refrigerator. Just look at the refrigerator, and Raspberry Pi will able to detect the refrigerator, and it will able to turn it on and off, and will able to control that. So these are electronic appliances. We need to list those electronic appliances that we want our ML module to be detected and controlled. So here I've listed the TV, laptop, mouse, and all those electronic. And you need to save it with the i.iot.tv.txt file or any other file name. And you need to put the same file name in the code. And next we will move to the code. So after this, we will save this file in the object detection data folder. After getting this setting done, you need to open the and this is the SSD mobile net model that you will be able to get on TensorFlow official website. You can search the SSD mobile coconut. This is a pre-trained model for detecting various objects like bird, car, refrigerator, and camera. If you want to make a custom object detection model, then then you can train the data set and create an ML model using the various platforms. There are various platforms out there in the internet, and they are for free, and you can easily create an ML model using those platforms like Google Teachables, the Lobe, or you can say the uh, uh, Age Impulse. So there are various platforms to teach the ML model. So here you can I have the Google teachables. So like this is a Google teachable. Also you can you can this you can open this, then you can click on image project, and then you can select and feed the data sheet with a webcam or with the or upload the file. So suppose that you want to train a data set, you want to train a data set, if you want to train an ML model, create an ML model to detect the light, refrigerator, 3D printers, or any other things electronic appliance that you want to control. So you need to simply name this with refrigerator or bulb, bulb bulb, or a TV, or whatever the things you want to control, and then you need to upload those photos of those electronic appliances, and then click on the train model, and then you will be able to export that train model, and you will use it with TensorFlow code that we are going to create it later. So this is how you can create a ML model, train the ML model easily. Open this any of this platform like teachables, and then name these things, the object that you want to control, and then upload the data set and train the model and export the model with SAP, whatever the model name is. So after doing that, here is my ARPA window, the Raspberry Pi desktop. So this is my pre-trained ML model that I have. So we will use this SSD mobile 2 version 2 model, that is pre-trained model to detect various objects. And after that, we will create a code. And here I have created the code IoT, and I here is. mm, I'm opening it in Python 3. So whole code is made in Python 3. If you are using the Python 2, it might face difficulty running the code. You might need to change the code. So you better to use the latest version of Python and latest version of all these modules, so that you are able to run the code without much error and hassles. So 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 here is the code, and so in the code you can see I've used I have imported a CV2 module, that is the OpenCV module. I've used this module to capture uh, the video from the camera, that the video from the camera. You can see here this video, this camera. And you need to also you also need a camera for this project. Like this, you need a camera and attach it with the DSI port with the Raspberry Pi like this. And after attaching this, you need to turn on the camera interface on using this configuration. You need to go to this, and then Raspberry Pi configuration, and in the interfaces you need to turn on the camera interfaces SSC and VNC, and whatever the interface that you are using for the camera, and using the camera interface. So after turning this on, you will able to, and using this OpenCV, you will able to get the camera interface on the Raspberry Pi, and you able to detect, able to get a video on the Raspberry Pi from the camera. And you can also use any other Wi-Fi cam, and for that IP cam as well. And here I've used the TensorFlow, uh, uh, imported the TensorFlow module to use the SSD mobile net um, ML module that we have trained, pre-trained module, that to use to detect the object. So after this serial command is for a next level. When we want to make our eyeglass, the eyeglass, for IoT system, to make it wireless, to wirelessly control the TV. When you look at the TV will wirelessly control by just by looking at it. But for here I am just using the wiring system. We will do it later. So we will talk about this later. So if you're using the wireless system, then you need to use this. So after that, here we need to define the TensorFlow module that you have created. Like you have created any particular type of other TensorFlow module, any another ML module on the Google Teachable to detect the light bulb or any other particular electronic appliance. Then you can set that module here. But I am using the pre-trained module that is available on the internet, that is SAP Mobile Net version 2 Coco module. So we will rename this module, or you can rename this module with your module that you have created. So this is the ML module that we are going to use to detect the object. So whatever the ML module you have or you have created, you have to give the path and the name of that module here in this part of the code. And after that, we have to set the path of the pb.txt file, which contains the list of objects, the name of list of the objects that need to be detected from the ML module. So here I have already told you the IoT.pb.txt, where it contains the name of the TV refrigerator or electronic appliance that I want my ML module to detect to control them. So you can set the path and that pb.txt file name that we have already earlier created in front of you just a few moment later. So after that, we can move into these things with the logic. So after this part of the code will actually capture the camera, and then they resize the camera video, and then convert into the RGB, and it process the image, and our TensorFlow module will run those you can say uh, uh, wait a minute. I have to first install the charger. Just wait one minute. Now let's proceed with the video. So after getting the TensorFlow module done on our board, uh, uh, and this part of code process the video that is captured from the camera, and after getting the camera capture the video, we will try to extract the results of the ML module. Like when the camera captures this camera captures the video, and this video will be processed with the with the TensorFlow and ML module. And after that, we will extract the result. What is the result of that ML? What are the object that it get detected using our ML module that we have created earlier. So after that ML module get created, and the result is output, we will create a various strings for the appliances, and check those strings in the result, like, because the result, what is the result, that output of the output of the whole TensorFlow and the image processing thing is done. It's in the form of a string. Using this command, we get the result in the string. So suppose that our camera have detected a TV, fridge, laptop, and all those objects detected in the video of the camera. So the ML model will output those TV, camera, fridge, uh, in the form of a string, and we will create certain variables like substrings to check whether those strings is present in the result or not. So suppose that our here I am checking the cell phone, laptop, or TV. So so it will check whether these substring are present or not, the TV is present or not. If the TV is present, then uh, we will create a if command. Using this is if command, we will create a logic. Suppose that you look at the TV with the eyeglass. You're wearing the smart IoT and eyeglass, and you just look at the TV, and you have no intention to turn on the TV or turn off the TV, or you want to control the TV. You want to control the user interface of the TV, or some. There's no intention of that. You just occasionally look at the TV. So how will your model, how will your code be able to determine its a casual look or its intended look to control the TV? So for that, I have created a logic. Here the logic is, if I have if I want to control the TV, then I look at the TV for more than 30 seconds, or more than 3 seconds, or 4 seconds, whatever the time you want to set in the code. So I have set it for the 3 seconds. So whenever I look at the TV for the more than 3 seconds, then our code will able to detect that, able to know this is not a casual look at the TV. Also, the user is looking at the TV to control it, and it will able to control. So for that, it will able to toggle the switch. This is not the final code. This is the rough code. Here is the final code. Here is the final code. so it will able to detect the TV or what will the object detected from that. So now let's try these things. uh, Now we will we will connect the relay module, this relay module. Let me show you the relay module. So this is the RPA that is to be mounted on this eyeglass like this, like I already have said, already I have I've shown you in this video, like this. This eyeglass is mounted. 1 minute. Like this eyeglass is mounted on the eye like this with the camera here. So whenever I look at the TV, it will able to detect the TV and all things. So this is RPI board, and then this is the relay module that used to control the AC appliances. Uh, AC appliance. So this relay module have any kind of this relay module have the three pins, like because it uh, have three. One is a common, that this common thing is connected to the live wire of the AC of the AC power supply, and then is NC and NO. This NC pin is NC is for normally connected. So whenever the relay is on off condition, the NC pin is connected with the common, so this circuit get completed, and NO pin normally open. So this normally open will able to conduct the electricity only when the relay module is on condition. So whenever the relay will turn off, the NO will get the power from the live wire, and whenever the relay is turned off, the uh, NC pin get the power from power cable. So we will connect this a common pin with the uh, live wire with the TV live wire from the power outlet, and NO pin with the TV live wire, and the neutral wire connected to the TV neutral wire, and the power neutral wire, and the earth is connected with the earth TV earth wire, and the power supply earth wire. And then you can see the various GPIO pins. So this is optocoupler relay. So these pins are connected with the GPIO RPI board. Here I have already attached a voice module. So I'm using the GPIO of this AI voice module, but this thing is not needed. You can change the pin number and use the GPIO Raspberry Pi or default GPIO RPI board. But I have already attached it, and it is hard to get it out from the RPI board. So I leave it and use its GPIO pin. So here we will take those connect this GPIO pin with the GPIO pin of the RPI board, or the AI board, for using which we want to control. And we also set the same pin number here. Suppose that this is AI board, and I'm using the GPIO pin number D to give the signal to relay module to turn on and off the TV. So I have to set those same things in the code here. You can see. Uh, One minute. Here TVD P number D I have already said. So whenever the code will able to detect the TV, and then it will check whether it is intentional look on the TV, or normal look on the TV. If it detect the user is have intentional look at the TV and want to control it, that when I look at the TV for more than 30 seconds, that it will automatically toggle the TV switch. That is it will toggle the GPIO pin number D of this board, and of this board, and it will able to turn off this LED. So now run the code and test it out. So here is the camera. So here is the camera, and here is the module, and I am running the code, and I am just minimizing it to the here. This is the camera, and suppose that one here. I have run the code. Now code is running, and let me check it here. So wait, we need to wait for the few seconds because this TensorFlow model need to be imported, and it will take time to import all the modules and ML modules and get the camera interface. So after running the code, you need to wait for the few seconds. Whenever you run the code, the relay light is turned on to the off position. So now this is the camera video. Now when I point this camera to the TV, this relay will turn turn off and toggle the switch, toggle the TV to turn it on and off. So whenever I mount this glass up here and look at the TV I will able to control the TV just by looking at it. So suppose that I am looking at the TV like this in the room, so it will able to toggle the switch like this. So it will detect the TV and it will toggle the switch like this. Just see, just see, just see. It detected the TV and able to toggle the switch. So this is how the system work. So so whenever you look at the light, whenever this camera, the mounted camera, look out on the light, it will able to turn off the light. So using this system, this whole system, you will now able to understand. We have created the ML module to detect the electronic appliances in our rooms, and whenever I look at the room, uh, uh, the uh, the the IoT system will able to know where I am looking at and what I want to control, and it gives me user interface of that and able to control that thing. So suppose that whenever I look at the bulb, I just look at the bulb and bulb will turn off. I look at the TV and I'm able to control the TV. So we need no remotes, no mobile phone. We just look at any appliances in the room and I will be able to control it. It is just like a magic, like you see in the Iron Man. The Iron Man in the sci-fi movie just look at the particular object or particular thing, and it will get the data details of that particular object in details, that who is the man, and he will able to control that things. So this is a similar thing. This is the smart glass, eyeglass. You just wear eyeglass and you will able to control everything around you. You can control the refrigerator, you will control the TV, you can control the light just by looking at it. So you need not to just turn the switch on off from the hand, or say the Alexa turn on the light, or say the Alexa turn off the TV. Just look at the TV and able to control it. This is just a cool magic of the electronics of 21st century. So this is how the system works. So let me tell you the let me show you the whole video of that thing. So this is the things. So whenever I look at the TV, here, let me tell you. So whenever I look at the TV, it will turn off and on and off. Just see. I'm looking at the when I look at the TV, it will turn off. And when I look at the phone start get charging. Just see. I look at the phone is detected and it gets charged. When I look at the TV is detected and it will turn and off, on and off like this. Just see. I came in the room and have a glance at the TV like this, and TV will turn off. I just look at the TV and it will turn on. And now I move and come again and look at the TV and TV will turn off. Just see, like this. So so you can control the many things around you, like refrigerator and everything, just by looking at them. You can customize this program, like you can create a smart watch, a smart glass with a small screen on that. So whenever you look at the TV, these things, this glass will give you the interface of the TV here, and you will able to move the interface using those eye movement, and able to control the channel number or whatever the things you want. So this is the next level of project. I am starting with the very basic thing, just by looking at the TV and detecting the TV. I'm not going to that this is another next part of the project that will coming soon in the next in upcoming sessions and on the website. But for now, this is so as you can see here, this is not the actual IoT, because the thing is directly with the connection of this board. So how we can make it IoT? By making it wireless. So to make it wireless, we need a few more components, like like Bluetooth module or any Wi-Fi module. So suppose that we will choose the Bluetooth module SC05. So Bluetooth SC05 will give you the Bluetooth connection with the RPI board. So now you can change the code. Here is the code. Here is the code. So I am turning off because here is the code. So here is the code. So after getting the Bluetooth module, we will program any microcontroller with the Bluetooth module to whenever this Bluetooth module receive a command or B command from this RPI board, it will turn off the TV or turn off the toaster or turn off the refrigerator. So here I will set the serial port here. Import the serial module, and then we will set the serial port for the Bluetooth module that is connected to the RPI board, and its baud rate and the component of the Bluetooth module. And after that, we will move to the next part of the question. So whenever I look at the TV and TV is detected and I want to toggle it, it will send the serial command B, this serial command B, or serial command A, or whatever the thing you want to send to the to the another of the Bluetooth device. So whenever this B is sent, the another receiver device Bluetooth module get these programs that whenever this Bluetooth receive the string A, it will turn on the TV or toggle the TV. So whenever you look at the TV, you will able to control the TV wirelessly. So when you look at the TV, you will able to control the TV wirelessly. Just or you can when you look at the bulb, you will able to turn on the bulb wirelessly. So you all you need to just need a glass, or you can even remove the glass. You can just fit a camera on different camera. This is another level of exploration of the project that we might convert into the next level. Might equip your home with a camera, and that camera will capture your head movement. So suppose that CCTV camera is is in your room, and camera is capturing your head where you are moving your head. And suppose that I am moving my head to the upward direction, and in the upward direction, the light bulb is situated. So this camera have able to get that I am seeing the light bulb, and if I am seeing the light bulb for more than 30 seconds, that will camera will know I want to turn it on, and the bulb will turn off. So this is another next level of the project, and you can convert this project and develop the project and innovate the project in many different ways. So this is the basic things that I have combined the futuristic technology and the latest technology, and able to do the things that is only possible in the sci-fi movie like Iron Man, where he will able to control the things just by looking at them. This whole things is possible now like magic with this whole set of project. So thank you. If you want to ask any question, you can ask me, or you can also contact me on my WhatsApp 7061 350 809 for more details, or if for any assistance regarding the project. So thank you everyone, and thanks all. And now you can ask the question to us. uh, One of the user asked apparatus. Yeah, you will get the whole bill of material and the things used in the project. The main things I've used in the camera module, RPI board, and the relay board, and the Bluetooth SC05 for the wireless thing, and the RPI 0W or Adreno or any another chip with the Bluetooth SC05 to control the things wirelessly. These are the things that I have used, and you can get the full details on the website and the article. You can search IoT on I by Aswini Sinha, or you can search IoT on I, and you will get. So thank you everyone. Thanks.